So here we are at the beach. You can see the ocean. This is the Pacific Ocean, and we're gonna be observing the waves. Let me tell you about the waves. Okay, so you see those waves, one here and here, going all the way back to the end of the way back. So let me tell you about what wavelength is. The wavelength is the distance between the successive crests of the waves, and the wave crest is the highest point, of course. So we have a wavelength, let's choose this wave, for example. These two waves. We have a wavelength between this distance and this distance. Obviously, I can't just, say what distance it is. But when you measure it, let's say that's 30 feet between waves. 30-foot wavelength, right there. The wave height is going to be the height of the surface wave. So what you see right now is the surface wave, and from the wave mean to the crest is going to be the wave. The wave frequency is the number of wave crests that pass a certain point every second or every minute, or however long you want to time it. So I'll show an example of waves passing from a certain point over 30 seconds. So here we see the waves coming to the shoreline, and as you can see, the line of the waves isn't a straight line, even though it's pretty straight along here, and it's kind of, it's still pretty straight right here, this line of waves. But as it gets closer, it gets more curved and more jagged, and that's because of the wave deflection, which is when the waves match the curvature and the shape of the shoreline, and that's why we have all these jagged lines of the waves, and why we start out straight right here, and we get very, very crooked and very curved the closer we get to the shoreline. So we see the waves more clearly as it gets into shallower waters, because the wave speed increases while the wave length decreases. Meaning that the wave overtakes itself, which makes the wave height increase. So if you could imagine something coming very fast, the water coming very fast in short bursts with less depth, it will start to overtake itself and crash along the shore.
Can we see any rip currents?
Currently we cannot see any rip currents on this beach. you could be able to tell if there were rip currents because they have a brown coloring, because the current takes this sand from the shore out further out into the ocean. So the sand is being brought out, meaning it kind of mixes with the water and it gives it like a brownish color. And of course, if you ever get caught in a rip current, don't be frightened. It's very strong, but all you need to do is swim to the sides of the current and you'll be good. You'll be out of it, and swim back to the shore. That's a good question. So, as we all know, waves, they're not a movement of water, they're a movement of energy. And every day, there's different tide patterns.
Tell me about the daily tide pattern.
Well, today, we can't really tell, because, you'd have to be out here all day observing the waves and the tides, which we're not doing. But you have three options. You have the diurnal tide pattern, the semi-diurnal, and the mixed semi-diurnal. If we were here longer than we are today, we'd be able to tell you exactly what is happening on today's daily tide pattern, but we can't right now. There's also physics that goes into the different tides and the different tide patterns. And that physics, it goes out into space, and it's mostly gravity. So factors that affect tide patterns, we've got gravity, we've got the sun, and we've got the moon. So you're going to have the sun, which is massive, as you all know. And you would think, maybe because the sun is so massive, it has the greatest impact on the Earth's tide patterns. It actually doesn't. The moon has the greatest impact on the daily tide patterns. And that's because it affects the water envelope of the Earth greater than any other factor. And that water envelope changes from different shapes, from an ovular shape and to a circular spherical shape. And that has to do with the different tides. You have the spring tide, which forms the ovular shape, and you have the neap tide, which forms the circular shape. So with the spring tides, you have the sun being in its position where it always is, based on where the Earth is. But you have the moon in a different position. The moon is actually either directly in line with the sun, or directly in line with the moon, the sun, and the Earth in between. And that causes the ovular shape because the sun is pulling one way and the moon is pulling the other. Or when the moon and the sun are in line near each other, the sun and the moon are pulling the same direction, pulling the water envelope one way, still forming that ovular shape. And then you have the neap tides. The neap tides are when the tides are less intense, because you have the sun pulling toward the water, the waves toward itself, but you have the moon, which has the greater impact overall on the side, like on the sides of the Earth, and not in line with the sun. So you have the tides being pulled towards the moon either way, and the sun pulling the waves towards itself, kind of balancing it out and making a spherical, more perfectly circular shape, meaning the waves are less intense. So, as you can see, the waves aren't all cut and dry, easy, simple stuff that just happen. It happens for a reason. There's physics, there's, geological science involved, and it's very important that we know the way the waves work, not only for curiosity purposes, but for safety purposes, especially in San Francisco and other coastal cities where the waves could devastate us and destroy us all. There's tidal waves that can be caused by landslides, earthquakes, or just any massive object falling into the ocean. Even something like the cliffs here. If these cliffs came apart and there was a massive landslide into the ocean, we would be at risk for a possible tidal wave, or at the very least a very large wave that could change the whole landscape of the San Francisco coast. So, waves are very beautiful, of course, but we also need to respect them and fear them because they have tremendous power, and we don't always know what's going to happen with them.